Okay, I've gotten the recording started. So, fractions, people, they're not great with fractions, and people hate fractions, and especially when it comes to solving and you have equations with fractions, and a lot of people get hung up on it. So, I thought I would do a session entirely on solving equations with fractions, because there's a shortcut, or not really shortcut, it's a trick called clearing fractions that we use, so that way you eliminate fractions from the equation, and then you don't have to deal with them until the end in case your answer comes up as a fraction. So the procedure for clearing fractions is to first determine the common denominator. It doesn't have to be the least common denominator, but that is the best choice, because then you don't have to reduce as much later on, but it doesn't have to be the smallest. Once you determine what the common denominator is, you multiply both sides by that denominator, by that number. And so that's the step that we call clearing fractions. Then you distribute, because you're going to have things with x and things without x. And so you need to distribute by multiplying everything by that number. Then you're going to get fractions, but they all reduce, and they will all reduce to whole numbers. That's the whole reason why we do this, is that all of these fractions will become whole numbers. If they don't, that means you made a mistake when you multiply by, either you multiplied incorrectly or you picked the wrong number. It's not a common denominator, because if you do it right, they'll all reduce to whole numbers, and then you don't have any fractions at all. And then you just solve like we do normally. So I've got two examples on this slide. So we're going to do the one on the left first. So we have 2/3 x minus 1/6 equals x over 9. Now, just a note here, that x over 9 is the same thing as 1/9 x. So if you don't like to see the x on top of a fraction, you can put it in front. Those are equivalent. And so that's important to know when you're simplifying, that that's what happens. I'm going to work with it with the x over 9 just so you can get practice with that. So for the example on the left, we need to get a common denominator. So we've got 3, 6, and 9. And 9 is not the common denominator, because you can't 6 times, there's no number you can multiply 6 by to get to 9. So I usually take the largest number, and then I'm like, okay, what's the next step? Multiplication, the next multiple of 9, which would be 18. And all three of those numbers go into 18. So that means our common denominator is going to be 18. So the LCD is 18 in this case. So we're going to multiply both sides of our equation by 18. So I'm going to start by rewriting the equation so that I can show that multiplication. So we're multiplying both sides by 18. And what that looks like when you have multiple terms is that you're going to have to distribute. So it's best to put parentheses around what you're multiplying, because the parentheses indicate multiplication here. And so you're going to want to make sure you have those parentheses there so that it's clear that you're multiplying. So when you're multiplying a whole number times a fraction, the tops of the fractions, the numerators, get multiplied by that whole number, because the whole number is 18 over 1. That's usually something that people tend to mess up. So if it helps, you can write it as a fraction, so that way when you multiply your fractions, you're multiplying the tops together and the bottoms together. So when I multiply the first fraction that I have on the left, I'm going to distribute. 18 times 2 is 36. So I get 36 over 3. And then I have my x. And 18 times negative 1/6, that's going to be 18 over 6. And then on the right side, when I multiply, I'm going to get 18x over 9. So I'm going to divide each of these fractions. They're all going to come out to whole numbers. So 36 divided by 3 is 12. So we get 12x minus 18 divided by 6 is 3. And 18 divided by 9 is 2. So I get 12x minus 3 equals 2x. So now we don't have any fractions. It took a couple steps. But now we have something that we can solve without fractions. It's a lot easier to work with because we don't have to then worry about a common denominator when we're adding or subtracting things. So to solve this, I want to have my x's on one side, and because the 2x, I have a side with only the x's, it would make sense if I subtract the 12x from both sides so that it is on the same side as my 2x. And I didn't quite give myself enough room here. It's thinking, wishful thinking that I had enough here. So 12x minus 12x is 0. I get a negative 3 equals 2x minus 12x. So you just do 2 minus 12, so that's negative 10. And then you have your x. So we have negative 3 equals negative 10x. And your next step is to divide both sides by negative 10 because we want just x. We don't want the negative 10 in front, and that's a multiplication. So we're going to do the opposite, which is divide. And this is we're going to have one more step that I ran out of room here, so I'm going to just kind of write it off to the side. So we get x equals, and then the negative 3 over negative 10, the negatives cancel out because a negative divided by a negative is a positive. And then we just have 3 over 10 as our final answer because we have a fraction there. So even though my x was on the right side, it's completely fine to flip-flop it and write it so that it's on the left because both sides of the equation are equal. So you can just flip which side is which. When you're writing your final answer, it doesn't really matter. But we do end up with 3 over 10 as our final answer there. So to recap, first, I had to find the common denominator, which was 18. Then I multiplied both sides by 18. On the left, that meant I needed to distribute. So I did that. And then on the right, I was simply just multiplying. And I divided each of my fractions, which gave me the whole numbers, and then I solved the resulting equation by moving things around. Because, I mean, the whole reason this works is because of the multiplication property of equality that you learned about last week, that you're allowed to multiply both sides of an equation by the same number. So if you do it smartly, that allows you to get rid of the fractions, and it gives you something that's much easier to solve. Are there any questions on this first example? Okay, so I'm going to look at the second one that I have here. We have 1 over 4, 1/4 x minus 2/7 equals 1/2 x plus 2. So we need to find what our common denominator is. And so I take the largest out of the denominator, 7. So 4 and 2 don't divide into 7. And then I'll say, okay, the next multiple of 7 is 14. Well, 4 doesn't divide into 14. So then I'll go to the next multiple of 7, 21. 4 doesn't go into 21. So the next one then is 28. So 4 goes into 28, and 2 goes into 28. So that makes my common denominator 28. I basically take the largest denominator, and then I check if the next largest goes into it. And then if it does, I check the next one after that. So that's how I determine my common denominator, which in this case is 28. So what this means is we're going to multiply both sides by 28. So I'm going to rewrite the equation. I'm going to try to give myself more room this time. And we're multiplying both sides. So we're going to have 28 on the left and 28 on the right. And we're going to be distributing both times. So when I distribute on the left, that's normal. Distributing on the right works the same, where you're still multiplying, you're just kind of doing it backwards. So instead of in the front, it's in the back, but it works the same way. So I'm going to start with the left side. So 28 times the 1/4, that's going to be 28 over 4x. Then I'm going to do 28 times the -2/7. So that's 28 times 2, which I think is 56, but I'm going to double check. Yeah, it's 56. So I'm going to have a minus 56 over 7 equals. Now on the right, I'm going to be multiplying by 28. So I have a 1/2 times 28. So that's going to be 28 over 2x plus then 2 times 28, which is 56. So that stays a whole number. So now that I've distributed, I'm going to reduce by doing all the division. 28 divided by 4 is 7. So we get 7x minus 56 divided by 7 is 8. 28 divided by 2 is 14. So I get 14x plus 56. So now we have our equation without any fractions, and then we can solve. So it doesn't matter whether you put the x on the left or the x on the right. I just like to put x on the left. I do that because when we solve inequalities, which is things with like less than symbols, you need to have the x on the left. So just to get into that habit, I always put the x on the left. So that is, I mean, unless there's a situation where then you have to do more steps. Like the first example I did, if I put x on the left, then there's more work. And in a case like this, where you have x's on both sides and numbers on both sides, I always put the x on the left, just for consistency. So that means I need to subtract 14 from both sides, or the 14x. So I'm going to subtract 14x. So 7x minus 14x is negative 7x. Then I have minus 8 equals 56. So now I'm going to add 8 to both sides. And again, I'm sort of running out of room here. Should have done one on a time. I thought these would be small enough to do on 2 of them here. So when I add the 8, that's 56 plus 8, which I believe is 64, but I'm just double checking. Yeah, that's going to be 64. And then we divide both sides by -7, because that's in front of the x. And that's going to leave me an x equals. Now 64 doesn't divide by 7. It gives you a decimal, so you're going to just leave it. And 64 over 7 doesn't reduce. So our answer is going to be a negative 64 over 7. So checking problems like this when you have fractions is harder. It might be, a little more confusing when you have to do things with fractions. So what I recommend for checking your work is to use Desmos. So I'm going to just bring that up here. I'll check both of these. Okay, so I've kind of shrunk it down so that you can see each of the problems. Oops. I was trying to put it back up. Okay, so instead of graphing calculator, you want to go to math tools, and then we're going to do scientific calculator. This will allow us to do fractions. So I'm basically going to check the left side and then the right side. So the left side I have 2/3. So I'm going to hit the fraction button, 2/3, and then it's going to be multiplied by x. And we solved x is 3/10. So I'm going to hit the fraction button again, and then 3/10. And so that gives you 0.2. So that's the left side. So now I'm going to check the right side. Oops, the left side has a -1/6. So I missed that. We can fix that actually. So I had 2/3 x -1/6. So I can go back here if you make a mistake, hit my minus sign, and then put in my 1/6. And so that gives us this number here. Right side is x/9. So that's going to be, we're going to have like two fractions here. So I had to hit the fraction button twice. So the first fraction is 3/10, and then that's going to be over 9. And so you can see we got the same answer. So that double checks your work here, is that you got the same number. And if you want to see them as a fraction, you can hit the fraction button. So they come out to the same thing, which is 1/30. So that means our first problem that I solved, we did that one correctly. The answer is 3/10. So now I'm going to go to the second one here. So I'm going to just do clear all. So the left side here, we have 1/4 x. So I'm going to put my fraction 1/4, and then it's times x. So x is -64/7. So to get the negative, you just hit the minus here. And then my fraction, 64/7. And then also part of the left side, we have this -2/7. So I need to hit my thing, so I'm to the right here, and then minus fraction 2/7. And then I'm going to hit enter. So now I'm going to do the right side here. We have 1/2, so I'm going to hit the fraction button, 1/2, and then times, and then our x. So I have a negative fraction 64/7, and then we have +2 on the right side. And so once you enter that in, you can see that our left side and our right side match. And you can, if it's easier to look at it as a fraction to make sure the fractions match, that's fine. So this is an easier way to check your work than doing all the math with the fractions, is just by basically using a calculator to put these in. And then you can see if the left side and the right side matches, that means that your answer is correct. So this is desmos.com/scientific. I know I've shared this calculator in the list of recommended calculators as an option because it's really great with fractions. So we've checked our work, which is great. So we know that these answers are correct. Are there any questions so far? Okay. So these, I knew were going to take more steps. So I gave myself the entire screen here. So here we've got 1/25 times 20 minus t equals 4/25 minus 3/5. Now, when you're trying to get rid of fractions, you need to distribute before you do get rid of fractions, because you might make an error. You can eliminate fractions now, but I tend to see errors when people do that. So I recommend first distributing, so multiplying this 1/25 first and then eliminating fractions. So that's what we're going to do, is we're going to multiply that through first. So 1/25 times 20, that would be 20/1. So when you multiply it, you get 20/25. And then when you multiply it by t, it just becomes the number in front. So we have minus 1 over 25t. And then the right side, we're not going to do anything. So that's going to be 4 over 25t minus 3 over 5. So always distribute first, and then you want to get rid of the fractions. So at this point, my denominators are 25 and 5. So it's pretty clear that 25 is going to be the common denominator because 3 of them have that number, and then 5 goes into 25. So our common denominator here is 25. So we're going to multiply both sides by 25. So remember, when you multiply, you're multiplying the tops of the fractions. So that's going to give us 25 times 20 is 500. So we get 500 over 25. And then we get 25 over 25t on the left. And on the right, when we distribute, we're going from the back. So it would be 25 times 4, which is 100. So that's 100 over 25t. And then 25 times 3 is 75. So that's going to be a minus 75 over 5. Be very careful. Don't accidentally multiply that bottom. Bottoms all stay the same. So now that we have all of these fractions, these are all going to divide evenly. So I'm going to do 500 divided by 25. So that gives me 20. And then 25 divided by 25 is 1, so I just left with the minus t. 100 divided by 25 is 4, so that's going to be 4t. And then 75 divided by 5 is 15. So we ended up with 20 minus t equals 4t minus 15. Now when you start getting good at this and you get practice with this, I usually skip the step above here where I write out my fractions. I'll usually do it all at once. I'll take my 25 times the 20, then divide by 25, because that's essentially what you're doing. You're doing your 25 times 1, divide by 25. And same on the right side, you would do 25 times 4 divided by 25. 25 times 3 divided by 5. So you're just multiplying by the top and dividing by the bottom. And I do that because I know it's going to be a whole number. So you can do that by, and it skips a step that you would write down. But I don't recommend doing that until you get really good at this, because this middle step is important for you to see what's going on and to understand and to double check your work. So I would not do that shortcut yet. So I've got these whole numbers now, and when I've got a variable on both sides and a number on both sides, that's where I always want to move my variable to the left. So I'm going to move the 4t to the left, and since it's positive, that means I'm going to subtract. So I'm going to subtract 4t from both sides. Now some people, and I'm going to show this to you, some people like to do multiple steps at once. So they might move this, and then they would also move their number. So if you wanted to do that, we've got this 20 that I need to put on the right. So you could do that in the same step. And if you're going to do that, I recommend maybe using 2 different colors so that you kind of keep that clear. I'm just going to show that. I generally don't really do that because it's easy to make mistakes that way. But I'm just showing that to you here in case that's something that if you're looking to save some time or some space, that you can do both of those at the same time. So 20 minus 20 is 0. And I have my minus 1t minus 4t, which is minus 5t. 4t minus 4t is 0. And negative 15 minus 20 is negative 35. So I was able to move both of those things at once, and it kind of just saved a step. So now I have negative 5t equals negative 35. And so I want to get rid of the -5 in front of the t, so I do that by dividing. So I'm going to divide both sides by -5. So that leaves me with t on the left, and then -35 divided by -5 is going to be a +7, which came out to a whole number for us, which is really nice. And it's actually a lot easier to check your work with a whole number. And again, you could use Desmos to double check your work by plugging it in on the left and then plugging it in on the right. And actually, let me show you an alternate. Let me pull up Desmos again. So let's say you accidentally went to the graphing calculator for Desmos instead of like the actual calculator. You can still use the graphing calculator here. So what you would do if you were to do the graphing calculator, you'd first just say, okay, what was my answer? T was equal to 7. So I'm going to just type that in. And we're just going to ignore the graph part and just look at the left side here. On the left, I have 1/25. And then in parentheses, I have 20 minus t. So you can see that it gave me 0.52, and if I want to make that a fraction, I can click that here. So it automatically plugged in t for us because t is equal to 7. Then I can click on the next line and type in the right side, 4/25 t minus 3/5. And then I can click the fraction to double check them. So I get the same answer here. So you can check your work in the graphing calculator as well. You can even do it. You can type in your answer and then type in the left and right side of the equation, and then that will check. I don't think you can. Yeah, it won't. Let's see. If you just type in the equation, it's not going to do anything. So you have to do the two parts separately. Oops. In order to check. But that's an alternate way that you can use to check your work in case you accidentally opened up the graphing calculator instead of the regular calculator. Any questions?
So this way that you're doing to, I guess, multiply the 25 across the board works for all fractions, like either adding, subtracting, multiplying, dividing. The reason I ask that because I know it gets different when there's one of them that you have to flip, like just flip the two numbers around. I think that's dividing or
something. Yeah. When you divide, the fractions flip. With multiplication, they stay the same. So you just multiply the tops of everything by that number.
Okay, so by this way, you can't do it with dividing them because technically be dividing the bottom number, correct?
Yes. Yeah.
Okay.
You have to do multiplication. If you divide, you would have to divide by the reciprocal. It'd be really gross. You don't want to do it. So
okay.
Possible, but we always want to do multiplication.
Okay. Thank you so much.
Yep. Are there any other questions? Okay. Here's another one. And here we want to distribute on both sides because, again, we have these fractions, but if you multiply the step, it's easy to make mistakes. So we're going to distribute on both sides. So I'm going to be multiplying the 1/12 times 4n. So that is the top 1 is going to be times 4. So that's going to be 4/12n. And then when you do 1/12 times 3, that's going to be 3/12 because it's basically 1 times 3. On the right, we have 1/4 times 2n. So that's going to be 1 times 2, which is 2. So we're going to get 2/4 n plus, and then 1/4 times 1 is 1/4. So I could reduce these fractions if I wanted to at this point, like the 4/12, the 3/12, the 2/4, I could reduce them. But there's really no purpose to that because you still want to get rid of the fractions. So I don't even bother reducing. I just go straight to the next step where you need to find the common denominator. So we're looking for our common denominator. We have two denominators here. We have 12 and 4. So 4 goes into 12, so the easy choice would be 12. So I'm going to multiply both sides by 12, and I'm making sure that I need to have my parentheses to indicate that. So my LCD is 12, and so then I'm going to distribute. So I'm going to do the 12 times the 4 over 12. So 12 times 4 is 48. So that's 48 over 12n. And then my minus sign, and then 12 times 3 is 36. So we're going to get 36 over 12. Now on the right, I am going to do the 12 times the 2. So that's 24 over 4n. And then 12 times 1 is 12 over 4. One of the most common mistakes I see is people people putting the wrong denominator, because if you're putting 12 and you're going over 12, it's really easy to just keep writing 12 once you move to the right side. So you always want to just double check your multiplication or just be very careful about it. Don't rush it. You can use a calculator if you want to double check your multiplication. That's fine. Just, this is where I often see errors, is like accidentally writing down the wrong denominator. So you just want to be very careful. So now I have all of these fractions that I can divide. So 48 divided by 12 is 4. Yep, that's 4. And 36 divided by 12 is 3. 24 divided by 4 is 6. We get 6n. 12 divided by 4 is 3. So we end up with 4n minus 3 equals 6n plus 3. So now we're going to start the solving process, and I'm not going to do the two steps in one. I'm going to do these separately just because that's what I normally do. And so I'm going to move my 6n so that it's on the left side by subtracting, since I have a positive. So 4 minus 6 is negative 2. So I have negative 2n minus 3. 6 minus 6 is 0, so all I'm left with is the 3 on the right. Now I'm going to move the negative 3 by adding, so I always do the opposite. That leaves me a negative 2n. Negative 3 plus 3 is 0. 3 plus 3 is 6. And then last step, I want to divide both sides by negative 2, since that's the number in front of the n. So I'm going to divide both sides by negative 2. And so that leaves me n equals, and then a positive divided by negative is negative. 6 divided by 2 is 3. So we end up with n equals negative 3. It's not too many steps, even though it looks a little more complicated. The more you do these, the more you get into the habit of, okay, I'm going to move something to the left, and then I'm going to move something to the right, and then I'm going to divide. You always get to a point where you basically are doing the same steps over and over again. Like once you get to this step right here, it's sort of the same thing each time. You move one variable to the other side, you move the number to the other side, and then you divide. So you're kind of doing the same procedure every time. And so that's one thing when you're taking notes and you're doing practice problems, is to note those patterns and notice, oh, I'm subtracting. I always subtracted this step, or I always added this step, and then we always do division as our final step. Noticing those patterns helps you, because then when you see something in the form that I have arrowed, if you see something that looks in that form with a variable and a number and then a variable and a number, you know what to do because you've done problems like that. So you're going to want to really pay attention to the form. And even if you're making notes to yourself, like variable plus number equals variable plus number, or even plus or minus to indicate that they could be subtracted, you can note that, oh, that's the form. So then what I need to do, you can just make notes to yourself, is first I'm going to subtract the variable from both sides. And then I end up with a variable plus a number equals a number. And then I subtract the number from both sides. And I get a variable equals a number. And then we usually divide. So, I mean, this is just kind of a shortcut notes to yourself of the procedure that you might want to note, but I want you to pay attention to those patterns and notice like you're doing the same sort of thing over and over again. Whether it's a positive or a negative number, the patterns tend to be the same. Are there any questions on this example? Okay. Now, this is my last example that I have for you guys, and this is a tricky one. I want to do this one because there's a way about how this is written that it's not so bad as it looks. So we have 4y minus 2 over 5 minus y plus 4 over 5 equals negative 3. So this is actually similar to on this one where I had that x over 9. I said, okay, note x over 9 is equal to 1 over 9x. We're going to do the same sort of thing where you're going to pull the denominator out. It's going to be 1 over that denominator and then times the top. So we're going to rewrite this. And for both of these, the denominator is 1/5. So we're basically going to rewrite this as 1/5 times the top. So that's 4y minus 2. And then I have my minus sign, and then my second fraction is also over 5. So I'm going to write that as 1/5. And then y plus 4. And then I have minus 3. So this is just an alternate way to write this. And I'm writing it this way so that you can see the distributing. And you can see what it actually boils down to. A lot of people get confused where you have multiple things on top of a fraction and then you have your single number on the bottom, and that's confusing for a lot of people. But if you realize that you're basically just taking the top and multiplying it by 1/5 or by dividing basically by that denominator, it looks more familiar. It looks more like something that we've done before. And so we're going to distribute just like we did on the previous problem where you have that number and then you have your parentheses. So we're going to distribute. So 1/5 times 4, we're going to get 4/5 y. And 1/5 times 2, and I have that minus sign, so that's going to be 2 over 5ths, or 2 over 5. Now the next thing, we have that minus. So when you distribute, that minus comes with it. So that's basically, we're going to treat this like it's a negative 1/5. So when I multiply, I'm distributing by negative. So a negative 1/5 times y is going to be a negative 1/5 y. This is the same as subtraction. Then a negative 1/5 times 4 is going to be a negative 4/5, or subtracting 4/5. And so that brings us to our equation with all of those fractions. So I want to kind of point out the similarity to what you had before, like from the top. Like here we've got 4/5 y, and then we end up with a minus 2/5 there. But because of this minus, like this would be y over 5 or 1/5 y, but we actually get a minus because of the minus in front. And same thing here. If I wrote this as 4 over 5, that minus is giving us a minus 4/5. So you can kind of note a pattern here in the little circles that I have, but don't rely on that because the signs can get backwards. So that's one reason why I don't kind of take that pattern, because usually the signs get all messed up when people do that. So that's why I rewrite it the way that I did, so that way you can make sure all your signs are correct, because sign errors are like one of the biggest frustrations that people have. And I still make sign errors. Like, I mean, they're just so easy to do. And so anything to avoid those, I try to teach that. The minimal number of errors you can make with your signs, your positive, negatives, the better you're off. So I've talked about that. Now I could add my like terms, like the 4/5 minus 1/5, minus 2/5, minus 4/5. It doesn't really matter. If you wanted to, you could add your like terms and then get rid of the fractions, or you can get rid of the fractions immediately. Most people probably want to get rid of fractions immediately just because they don't even want to try to add fractions. So that's what we'll do. So all of our fractions here are the same denominator, which is 5. So that's going to be our common denominator. So we're going to multiply both sides by 5. On the right side, that's nice and easy. Just we're going to get a negative 15. So on the left, I'm distributing. I'm going to have 4 things that I'm multiplying here by 5. So I have my 5 times the 4 over 5. So that's going to do 5 times 4. I get 20 over 5y. My minus sign. Then 5 times 2. So I get 10 over 5 minus sign. 5 times 1, so that's 5 over 5 y. Then another minus sign, and 5 times 4 is 20 over 5. And then on the right, negative 3 times 5 is negative 15. If you're someone that needs help keeping track of this, you can draw an arrow each time you do your multiplication to make sure that you've done them correctly. And that's often what I'll do, especially with a lot of multiplications, is each time I do a multiplication, I draw an arrow so that I know what I'm multiplying. So now that I've got these fractions and I've multiplied through, I'm going to do my division. So 20 divided by 5 is 4. So we got 4y minus 10 divided by 5 is 2. 5 divided by 5 is 1, so I have a minus y. And then 20 divided by 5, that's 4 again, so that's a minus 4 equals, and then my negative 15. So now I'm going to add my like terms. It's a lot easier when you have whole numbers here and maybe when you have fractions. I don't mind adding like terms with fractions, so I probably would have done it at our step where we had all the fractions, but I know a lot of people are not comfortable with fractions, and so they would prefer to do it with whole numbers. So that's why I've done it this way, because I know that most people are not as comfortable with fractions as I am. So once we have these whole numbers, I need to add my like terms. So I've got like terms here with the 4y and the minus y. So they're on the same side, so you don't need to change the sign. So I just do 4 minus 1, which is 3y. And then I've got my minus 2 and a minus 4. So those are on the same side, so there's no changing of signs. And then minus 2 minus 4 is minus 6. And then I have equals negative 15. So I'm solving for y, and so we always do our addition before any division. So I need to add 6 because I need to move the minus 6 first. So I'm going to add 6 to both sides. So that leaves me with a 3y, and then negative 15 plus 6 gives me negative 9. I've run out of room here, so I'm going to just kind of go into the side here. If you're going to do something like that, make sure you do an arrow so we know where to follow. And I'm just going to rewrite that last step. So normally if you have a piece of paper, it's pretty easy. You have plenty of room. On a slide on a computer screen, I'm kind of limited. I can't scroll it vertically or anything. So we have 3y equals -9. So I need to get rid of that 3. We always divide at this step. It's always division. Just like we always multiply to get rid of fractions, that last step, that last step is always division. So I'm dividing both sides by 3. So that leaves me with a single y, and then a negative divided by a positive is a negative, and 9 divided by 3 is 3. So we end up with y equals -3. And then, of course, you can check your work. Are there any questions here? Oh, good. I'm glad it was a great explanation. Sometimes I feel like I do too much explanation, but I like to explain why I do what I do, because that way you guys can understand, and hopefully that helps teach you the same sort of thinking. Because part of doing math is not just like following the rules, but knowing why you make certain decisions. You know, why is it better to do this at this step versus at another step, that kind of thing. Yeah. That first problem, a lot of people see something like how it's given and they get very confused, very, very confused. And just as a forewarning, something that you see at the top there, something in this form, this is something that you'll see if you go to college algebra. We see that form a lot with rational equations. A rational equation just means you have an equation with fractions. So technically all of these are also considered rational equations, but the ones where it's more complicated in the fraction, especially if you have once you get to college algebra, you'll have letters in the denominator. That's really where you'll see this, and they get more complicated. And so it's the same sort of steps. We're still trying to eliminate fractions. It's just like when you go to college algebra, we ramp it up a step. Like, oh, we had variables on top, now we're going to have variables in the bottom. So it's just same thing, just added complexity. So just something to look out for if you have to go on to college algebra is if you keep these notes handy, you can say, I saw something similar. How did I solve it then? Now, how do I apply that same thinking or those same steps? Because they are basically, it's the same thing, just with, you know, throw in a couple extra things there. So that's all the examples that I had. Hopefully this makes you feel a little more comfortable with fractions. If you are someone who is uncomfortable with fractions, I have to go back out to Desmos here. But this scientific calculator, if you are not comfortable with fractions, I would recommend using this. You can do this to multiply your fractions. I think I'd rather have you do that with this than to make a mistake, you know, when you're dividing fractions or things like that. So I do recommend utilizing the fraction button. It's important to understand how fractions work, and multiplying fractions by hand is a good skill, but, you know, don't be afraid to use technology if you have to. Especially on like a quiz, I'd rather have you use the fraction button here and do all your fractions here than to run out of time on the quiz. But it's important to know, you know, how to work with them. And clearly a problem like this, you can't just put this into the calculator and it does it for you. You have to at least know how to rewrite the fractions and have some understanding of what's going on.